Hi everyone, myself Dr. M. Lakshmi Prasad, working as an associate professor in the Department of Data Science in Institute of Aeronautical Engineering. So in this video, I'm going to discuss about uh, diagrams. So what are the various ways of presenting the data? So for that, diagrams also very important. So till now, what I have discussed here is the presentation should be in the form of tables. So that one I covered in the previous video, and then I also covered about the graphics. So graphs are also very important for presenting the way of representing the data, where the data is going to be getting from multiple sources like primary source and secondary sources, and diagrams. So diagrams also very important for representing the data in order to present it, right? So for that we're having different types of diagrams. So what are the different types of diagrams for representing the data? That and all I'm going to cover in this video. And so before going to see that about the diagram, so first of all you have to know about what are the rules that are going to be followed for drawing the graphs as well as the diagrams, right? So for that, what should be the rules we have to be seen now? So very first one is that the first we have to choose the right diagram, so which is capable of representing for given set of data. So that means that so already you are having different types of diagrams. So for any kind of application, we can able to draw different types of diagrams, right? So for that application, what is the best and suited diagram have to be identified. For that, we have to be very familiar with the diagrams what are available for a way of representing the data. So in previous video I discussed about the graphs. So in similar fashion for that application, so we have to be choose the right graph, so which is the best one have to be identified. So for a simple application I can able to represent a multiple bar and bar diagram, and then I can also represent the same thing multiple bar diagram in a multiple bar diagram itself. So right, so that means instead of representing two simple bar diagrams, I can able to represent it in a single one diagram that should be multiple bar diagram. So what is the another way of representing this multiple bar diagram should be the line diagram, which should be on 3D form. That should be very best way of representing for that application. So like that, in similar fashion have to be identified, have to be choose the right diagram for that given set of application. And then the title, so the title also important, which gives the information about the diagram what it contains, so that the title have to be mentioned. And next one should be scale. The selection of scale should be neither too small and then neither too large also. So what is the scale of the diagram? So that should be the size of the diagram, that should be very should not be too small and should not be too large. So it should be some medium size is the preferable one, so which can able to represent better view. So representing small size and large size. And next one is that neatness. So neatness also very important. And then attractive. So attractive in the sense where you can able to represent different types of lines or shades or colors. I can able to represent to make the picture to be more attractive, right? So suppose within this, instead of representing black line, I can able to give some different lines or different shades or different colors. I can able to represent so that the presentation should be very attractive one. And then originality. So originality also makes the observer to see the details with very accuracy. Suppose what is the suppose if we are going to show duplicate details, the observer may not be that much interested. So originality of the content is very important. So what is the diagram, what is the data is coming from, and whether it is from primary or secondary, like this have to be identified. Suppose if the data is coming from secondary source, the observer may not be that much interest to show on this presentation. Suppose if the data is coming from primary, then it should be very important so that the observer can able to see the details more accurate in detail. And simplicity. So simplicity also another way of representing good diagram, depending upon the easiness of the observer, easiness where we can observer can easily interpret it, right? So simplicity means it should be a very simple one, so that the observer can able to interpret the data what is representing in the presentation. So that should be easily analyzed and easily interpreted. And economy, so economy is also important, where the cost and labor should be exercised while drawing the diagram of a particular application, right? So these are the some of the rules what we have to be follow for the drawing diagrams. So very first one should be the choose the right form of the diagram. So whether for any application, so what will happen, there will be different types of diagrams, right? D1, D2 and D3 and D4. Suppose for if I'm going to choose the D3 is the best one, so that I can able to choose, so that the presentation should be easily, and then the analyzer or observer can able to analyze the data very clearly and all. So before going to draw this, so mention the title. So title is very important, and then the scale. So scale is also important, whether the scale, and that means the picture size should not be too small and should not be too large, right? And then neatness is also very important. Attractive, so attract, how to make the presentation to be attractive means where I can able to apply different types of lines and different types of colors or shades. I can able to apply it, so to make the pictures to be more attractive. And originality, so originality is also important, so in order to make the observer to be uh, to see the details should be with very accuracy. And then simplicity, so simplicity also important, in order to make this diagram should be good one, depending upon the IC, so where the user or observer can able to interpret it. And then economy, so economy is also important, where the cost and labor should be exercised based on exercising the diagram what they are going to do. And this one also covered in previous, like what are the differences between the graphs and diagrams. So very first difference is that in order to construct a graph, what we're going to need, a graph paper is going to be needed, whereas the diagram is going to be represent, we have to need a plain paper. And the graphs what is representing means, so the graph should able to represent the mathematical relationship between the two variables. So whereas the diagram does not represent that kind of relationship between that. And the graphs are also more appropriate diagrams to represent the frequency distributions and then time series, right? So the graphs are the more appropriate than the diagrams to represent the frequency distribution and then time series also. So the diagrams what are going to be used are going to represent the frequency distribution. And then the diagrams are more attractive to the eyes, so that it can be better suited for the publicity and the propaganda purposes, right? So what is the diagram? So instead of representing the graphs, they are not that much useful and that much attractive to the eyes, right? So the diagrams make this observer to make the application should be more attractive and then best suited for publicity also. And the diagrams does not need anything to meaning of the data, hence they are not helpful in the analysis of the data, right? So what are the diagrams are drawing for publication, so that not need anything and does not mean any meaning represented. And this one also not helpful in the analysis of the data also. And the graphs what are going to be represented, that should be used by mostly by the statisticians and the research workers in their analysis, right? But the diagrams are not that much useful by the statisticians and researchers, so the graphs are the important one. So just like in previous one, I discussed covered about the graphs, right? So what are different types of graphs, like histogram and the frequency curve and frequency polygon ogives and the line graph. So these are the some of the different types of graphs what we're having. So in this video I'm going to discuss about the diagrams. So the diagrams will be of two types. So very first one should be bar diagram and then pie diagram. Again, this bar diagram is divided into simple bar diagram, multiple bar diagram, and component bar diagram, percentage bar diagram, and deviation bar diagram, like this. So these are the some of the different types of diagrams that one can able to see in this video. So we see the very first one should be the pie diagram. So what is the pie diagram? So many of the people know how the pie diagrams look like. So this is the view of the pie diagram, and this pie diagram also can able to call it as a sector diagram. And this pie diagram can able to represent the discrete data of qualitative characteristics such as blood groups, RH factor, age group, sex group, causes of mortality, social group in the population, right? So this pie diagram can able to represent the discrete data of the qualitative characteristics. Examples like blood groups or H factor, age group, sex group, the causes of mortality and social group in the population. And the frequencies of this group are going to be shown in the form of the circle, and the degrees of the angle are going to denote the frequency and the area of the sector, right? So what is the circle you are taking? That circle is going to be divided into different frequencies, and these frequencies are going to be where the angle, right? So these angles are there, right? So that angle is going to be calculated based on the frequency and then area of the sector. And it also gives the quick comparison between two things at a glance I can able to show. And the size of the each angle is going to be calculated by frequency, by total frequency. That one should be multiplied with the 360 degrees. So this is the size of the angle. Suppose if I want to know this, suppose 56%. So what I am going to do, I have to calculate this angle. So how much angle this one? So for that, what I have to do is the size of the each angle is going to measure in the form of degrees. So for that, what should be the equation? The frequency and the total frequency, and that should be multiplied with the 360 degrees. So that should be the pie diagram. So where the degrees are going to angle showing to represent the frequency and the area of the sector, and then which should also give the quick comparison or quick difference at a glance I can able to represent through the pie diagram. And the each size of the angle is going to be calculated by the frequency by the total frequency. That should be multiplied with the 360 degrees. So let's say this. Suppose I circle is equal to 100% of the data, right? So first of the steps we have to follow is, so first we have to draw the circle, right? So once you draw this circle, so what you have to do, find the center point of this, of each point, and try to calculate the radius of the circle here, and then use some protractor to make the angle. Suppose this is the protractor showing the diagram, right? So how much angle I have to represent it? So the first one, suppose the distortion phase representing as 62%, make an angle of this and then make an angle of 62%. Suppose and it should be 62%. That should be the distortion phase and all. So this is the angle what they are going to show the pie diagram. It should be a 3D pie diagram. And again, extend what I have to, what should be the room, how much that should be occupied by the person, that is 17%. So make use of this protractor and make it of 17%. Make it as a different color or different shade I can able to do. And then next one, suppose if it is again 10%. So if I want to represent, make a protractor, make use of this under sector, and then make use of a different shade like this. So it should make this some little bit difference to the one sector to the other sector, and there's some 25% if I want to represent it. So how to make this pie diagram should be clear, and then so that the users or observers can observe this data very clearly, how much percentage of data it is occupying, by based on the application, or by seeing the application the users can easily understand. Let's say this favorite color. So what should be favorite color? So frequencies are available, so yellow, green, red and purple. So I want to calculate the blue color. So 6 is the frequency, right? So for that 6 is the frequency. So what I have to do, I have to make an angle of 54 degrees. So how can I able to get the 54 degrees? So 60 by so what is the total frequency? 40 into 360. So 54 degrees. So this is the angle I can able to get it. So similarly yellow. So how can I able to get it? So 90 by 360 into 360. Sorry, that is 10 by 40. So 10 by 40, 9. So 90 degrees. So like this I can able to get this angle of 90 degrees of yellow. So I can able to make it as a different shade, or I can able to apply a different color. And this 54 should be blue, right? So I can able to do this with the blue color or what, or I can able to use a different shade. So I can able to this other colors. My other means 70. So 70 by 40. So that 40 is the total degree into 360. 9. And 7 is 63. So 63 angle I want to represent through other. So 63%. So I can able to represent like this. See the example. So the following table gives the monthly expenditure of the family. So that is going to be represented by means of pie diagram. So and these are the items that is going to be spent by many of the family members, like food. So what is the expenditure? 1,050 for clothing, 650, and then house rent 500, education 350, fuels 200, and others 250. So for that, what I have to do, I have to make a pie diagram. So the pie diagrams make the picture to be very clear. So what is the best, more expensive I can able to identify, and then what is the least expensive I'm spending, and that one should be going to be identified very clearly. So this is the foot. So it should be of 126 degrees. So make a circle first initially, and then make a radius, and then draw a circle. Should be 120. Make use of protractor, and then make use of this 126 degrees. And then next one, clothing. So again make it of 78 degrees. So this is for clothing. And then house rent, 60% house rent. And then education, and then fuel and others, like this. I can able to draw the pie diagram. So by seeing this diagram, I can able to I'm spending more expense on this food, and then I'm spending more expenses on next is that clothing and then house rent, like this. I can able to do. So where I'm spending least expenses, that should be fuel. I'm spending fuel, right? So fuel is the least. So I'm able to make the picture to be very clear, and then many of the people can understand very clearly. And the next one should be the bar diagram. So the bar diagram should be consist of the series of rectangles of bars of equal width they have to maintain, and then these bars are going to be standing in a common baseline with the equal gap between the one bar to the another bar, and the bar should maybe either horizontal or vertical, and the bars what they're going to be constructed in such a way that the lengths and proportional should be magnitudes. That should be the frequency here. So the bars what I'm taking, so I can able to represent in the form of horizontally, or I can able to represent in the form of vertically. So these are the different ways of representing the bar diagram. So the spaces between these two bars should be consecutive, equal. We have to equal width we have to maintain, and then the bar width should also be equal. Okay. So that should be the bar diagram or bar chart. So the bar diagram consists of several rectangular bars of equal width, but all these should be on the basis of this same line. So I can able to represent this in the form of horizontal bar, vertical bar, and this should become x and axis, and this should become y axis, and this is x and this is y. So I can able to represent it. Okay. And next one is simple bar diagram. So in simple bar diagram, so where I can able to represent only the bars of equal width. So this one is going to be used to represent where the items are going to be compared with a single characteristics. Suppose I want to compare the characteristics like nicest fruit, I have to find it out. So whether it is apple or orange or banana, kiwi, blueberry or grape. So what is the nice fruit I have to find out, right? So for that you have to make your simplified. So where this, when I'm going to apply this, means all the bar diagram should apply to a single characteristic only. Okay, so at the time I have to make use of simple bar only. So here the items are going to be represented by rectangle bars of equal width, and the height also proportional to the magnitude. And the bars drawn what I'm going to be done on baseline, so it would be of equal distance, and then consecutive bars are to maintain, and all the bars should be maintained shaded by the different colors so that they make this bar graph to be more attractive, so that everyone can able to easily identify, right? This is the simple bar. Suppose if I'm going to represent, see another example. So example shows the way of children travel to school in one of the classes, right? So how the school persons are, most of the school people, school children are going to be, what should be the transportation, their transportation I want to know. So I have to represent how many students are coming by bicycle, and how many students are coming by bus, and then by car, and then I have by walk how many people, and scooter, train, like this I want to know. So I want that a simple bar. So it's here also that sheet is going to be presented with the single characteristic only, right? So at that time I have to make a bar diagram of equal width and equal space should also be maintained. So by seeing this, what I can able to analyze, so the many of the school children are coming by walk only. So what is the least? So that means many of the school children are coming by bicycle. So this is the least one, and this is the highest number of students I can able to identify. And then the number of deaths I have to identify, that should be pneumonia. uh, I want to find it out. So chronic respiratory disease, and next one is pneumonia, and then vascular disease and disorder of the heart. So these are the how many I want to find the number of deaths that should be done through chronic lower respiratory disease and pneumonia and vascular disease and disorder of heart. I want to find out. So at the time also there should be one of the application. So what I have to do, I have to make use of this uh, bar diagram here. So for that I have to draw the line. So for that I want to represent 1594. So in between this, right, I have to make the bar diagram. And similarly I have to draw 3263. Like this I have to draw the bar diagrams. So again, this bar diagram can able to divide it in different types. Suppose if I'm going to further divide this bar, then it should be component bar diagram or stacked bar diagram or proportional bar diagram. So these are the some of the different types of bar diagram. So here what will happen? So the bar within the single bar, I can able to represent the portion of the different characteristics. Suppose I want to show this number of in a city, how many number of peoples are having blood group O, blood group AB, blood group B, blood group E. I want to show this is the cities, right? So this is the city 1 and city 2 and city 3. I want to know how many number of people are having this blood groups. I want to find out. Similarly, I want to find out how many number of people are having the blood group in city 2. Like this I want. So here I'm going to compare with the two different characteristics, right? So I have to make use of this proportional bar diagram. Here the data items what are having magnitude should have two or more components, and then the items are going to be represented by rectangular bars of equal width, and height is going to be proportional with the magnitude. And this the bars are going to be divided in subdivisions into height with respect to the components. And then in order to make the distinguish between the components, so from one another to another very clearly, so what you have to do, I am going to apply differentiate. So this is the this color is going to represent blood group of A, and this is the color is going to represent blood group B, and this is the color represent blood group, and this is the color of, so that what will happen, so that I can able to clearly understand what is this color and how many people are having this blood group by seeing this index of the bar diagram. So similarly I can able to draw for the city 2 also and city 3. And this is the another person. So example showing that the strength of students in nursing degree course, right? So I want to find out, suppose in BSc, first BSc, how many number of boys and how many number of girls are available, and second BSc, how many number of boys and how many number of girls, and third BSc and fourth BSc I want to know. So strength also going to present it. So what will happen? So I want suppose the number of first BSc will be boys will be 10 and then girls will be 40. I want to. So first make a broad diagram. The first one 10 and here from plus 40 how much to draw. So total number of students should be 50 in the first BSc. Similarly second CSC, second BSc the number of boys should be 7 and girls should be 38. So totally how much? So first you draw the 7 here and then draw 38 from here onwards. So what will happen? 45. So 45 is the value. So like this I can able to draw the example of a bar diagram. And next one is the percentage bar diagram. So what is percentage bar diagram? So this percentage bar diagram able to represent whose magnitude are going to be two or more components, and then the comparison of the components are going to be represented in the form of percentage, and then the totals of what are going to be given. So that totals are going to be represented by bars equal width and height that should be equal to 100 each, right? So the percentage should be matching with the 100. So 100 is the common. So the height of the bar should be 100 here, and then so the here this bar diagram is going to be divided into three sections of three different colors. So how many number of uh, men are going to be see dance and then TV and then sports I want, right? And similarly how many number of people are going to be see dance, TV and then sports I want. So percentage means that should be mapped with the 100% only. Suppose in previous diagram here also that should be mapping with the uh, not mapping with the 100 here. So the percentage bar diagram means so the bar should be compulsory matched with the value 100, and that one is going to be divided into three different sections based on the application. So the bars are going to be divided according to percentage components and the different subdivisions what they are going to be shared. So that should be properly indexed and then properly shaded so that in order to make the ambiguity and all. So the percentage bars are going to be useful in comparing the percentage components mainly, right? So that should be the example of the percentage bar diagram. So in percentage bar diagram what I'm going to do, so the bars should be of equal to 100 and that one is going to be divided and based on the application. So men and women, I want to know how many number of people are going to see dances, TV and then sports. And the next one is so similarly I want to find what should be the percentage of fats, of proteins and then carbohydrates that is going to be taken out by the poor community and then rich community. I want to find out. So for that what I have to do similarly this I have to first draw this diagram to 100. So I want to find the percentage of fats in poor community. It should be 80 and then protein is 10 and then uh, carbohydrate is also 10. So total should be 100. So this one I have to represent, right? So first 10 write down and another 10 10 and the next one is 18 should be equal to similarly I have to find out in a rich community also. So for that the energy fact should be 55, 30 and then 15. So for that first draw this 15 from 30 and then 55. So if I'm going to add it should be also equal to 100 and then make a shade of different shades or different patterns. I have to make use of this now to make the picture to be very clear. And the next one should be multiple bar diagram. So in multiple bar diagram, so what does this say here is, so here we are going to be used two or more different patterns or different set of values are going to be used and multiple bars are going to be drawn here. So example imports and exports. So what is multiple bar diagram? So within this I want to know. So in 2009, so how many number of sales are going to be done in north side, south side, east side, west side. So for that I have to make use of four different colors. So I'm showing it in multiple bar, and then so the set of rectangle bars are going to be equal to the height of the proportion to its value, and the bars what should be drawn, so that should be corresponding to the same place adjacent to the one another. And the bar the diagrams what is going to be shared properly that should be an index that should be also going to be provided here, right? So in 2009, what is the sales? What is 2010, 11, 12, and 13? So how many number of sales that is done in north side, east side, west side, and south side, right? I want to write. So that should be represented not through a simple bar diagram. So it can be represented through multiple bar only. So the year wise, right? So see the examples of previous example I'm considering. So here also, so in first BSc, so how many number of boys are available? 10. How many number of girls are available? 40. So it's the same thing what I represented here in the simple bar I'm representing here. So in single bar only I am representing. So same thing I can able to represent the multiple bar also. That should be this one. So we can able to maintain multiple. This is the one bar for representing boys, and this is another bar representing girls, and this is another boys representing boys, and this should be girls. So second BSc, third BSc, and fourth BSc. Like this, I can able to represent different types of colors. I can able to make the bar diagram should be more clear. And then what should be the next is deviation bar diagram. So what is the deviation bar diagram? So deviation means here the deviations might be presented in two ways. So first one should be positive deviation and the negative deviation. So this deviation bar diagram is used for representing the net quantities which have both the positive and negative values. So some data is what I'm getting, so that should be come from different values like positive and negative values, right? So for that, what I have to do, I have to represent that one also. What is the positive and what is the negative? So that at the time I have to make use of this deviation bar diagram. So this is the diagram what you are showing on the screenshot. That should be a deviation bar diagram. So here first write a line, so 0, 2, 4, and this under the positive values, and downside that should be downward direction, and this one is upward direction. So what is the value that is coming from upward? That should be positive, and the downward should be negative. So most of the time this should become seen in census, right? Since census record, I'm going to see this type of deviation bar diagram. So census rate. So if it is moving upwards, that should be means positive, and this is also positive. And sometimes it is becomes a downward direction, moving downward. So what will happen? It should be negative. So like this, I can able to understand the positive and negative deviations also. See the example. So this is the variation difference in different budget in different areas. So administration 200 budget and variance is 25. For nursing actual one, budgeted one, and the variance, how much difference. So I want to represent it. Suppose in administration that should be what, how much difference it is, 25. So administration it should be 25. So for that one I can able to, for nursing it is minus 20. So how can I able to, I have to move represent it in downwards direction, minus 20. Pharmacy minus 5. So minus 5 means again I have to draw in downward direction. So center 5 plus 5. So I have to draw in upward. Radiology again plus 10. So like this, I can able to make this a deviation bar diagram. So it should be contain the positive and then negative values. See the other example. So 1985, 86, how many number of sales? So 50% and 10%. Sales is the 10%, and then net profits that should be 50%. Similarly, 1986 to 87. So 14% sales and net profit will be 20 minus 20. So that's why I'm going to draw in downward direction. Similarly, next one should be 1987 to 88. So how many number of sales? Positive 12 and net profit minus 10. So that should be. So like this, I can able to draw the multiple deviation bar diagram. So another way of representing this data is, apart from diagram, is stem and leaf diagram. So this is also very important and basically easy way where you can able to organize the large amount of data, and this is also be a special table. So where each data value is going to split into leaves, usually last digit, and the stem and other digits, right? So the stem and leaf plot is should be very easy where you can able to represent the large amount of data, and the special tables are going to be used where the data value is going to be split into leaves, and that should be normally a last digit, and into stem that should be a that should be and the digits will be the stem here. So the stem values are listed down, and then values goes right or left from the stem value, and the stem value is going to be group the scores and individually the individual scores within the group, right? So the stem values are going to be listed down, and then values are going to move from right to left from the stem value, and all the time this stem is going to be used to group the scores as a leaf, which is also going to indicate the individual scores. And this one is the examples of presenting stem. So the example is going to be presents the pulse rate of 19 samples before and after intervention. So what will happen is, so I have to identify the person 19 samples, right? So I can able to start with the age of 6, 7, 9 of different ages I'm taking. I'm going to identify that pulse rate here. So what should be the before intervention, after intervention I want. So at the age of 6, the pulse rate will be 988, and after that, same thing, nothing is going to be done. So similar at the age of 7, what should be the pulse rate? At the age of what should be the pulse rate? So before that it is 8862. Now after it will become 6788. Now similarly at the age of 11. So what should the pulse rate? So before it is 0, but after it is 11. So like this is one of the best example of representing the stell leaf. So where I can able to represent 19 samples before and after in intervention, right? So that should be about various diagrams that is going to be used for representing the data, right? So in this video what I covered is, so in this video I'm going to cover about the diagrams. So diagrams will be of different types. So bar diagram, and again this bar diagram will be of simple bar, multiple bar, component bar, percentage bar, and then deviation bar. So the bar diagram, we are able to use this representing the discrete data qualitative characteristic. Here I am going to maintain the circle here. So that circle have to be divided into different sectors based on the frequencies of the group, and this one can be able to further divide it by make use of this protractor and all, and the angle is going to be calculated. And this is the example of the bar diagram in 3D form. And these are some of the examples. And next one is bar diagram or bar chart, where you can able to represent this bar diagram in either in horizontal way or vertical way. So the simple bar, which if I'm going to show the single characteristic, then how to make use of this simple bar, and this is the example. And there is this bar also further divided like a component bar or stack or proportional bar diagram. That means within the simple bar, I can able to divide bar in different sections. That should be the proportional bar diagram. And percentage bar diagram is where the bar is going to be mapped with the 100 value equally. So based on that 100 is going to be further divided into different parts. And deviation bar diagram. So deviation bar diagram means which I am going to maintain the positive and negative deviation. At that time, I have to make use of this deviation bar diagram. Suppose if the data is getting some positive and negative values, so I have to make use of this bar diagram only. So deviation bar. And stem and leaf. So this is also a very quick way to organize the large amount of data. So where the stem leaf become the last digit and stem become the other digits. Okay. So this is the example of the stem and leaf diagram. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.